This iPro started as a collaboration with Dr. Gum Ephraim Grace Gengamoy, an anesthesiologist and engineer in Uganda, based on his original innovation of a surgical lighting system literally made from pots and spare car parts. The following are two videos sent to illustrate some of the main problems he wanted us to address.
You can see the number of students, there are so many, some of them have to climb up so that they can be able to see what is happening. It's only one which is working.
The goal of this iPro is to create a surgical lighting system that is energy efficient, has a backup power system, and can be reproduced with locally obtainable materials. For this, we have designed a head-mounted light and a ceiling-mounted light, keeping the lighting systems available in the United States in mind. In this first prototype, our goal was a wearable headlamp that always points where the surgeon is looking and does not allow shadows. We tried to eliminate shadows by creating 3 point sources of light. One of the main problems with this prototype is the fact that the copper tubing is actually too rigid and very difficult to move. The other problem is the fact that it is too big and too heavy for the wearer. In this next prototype, we made the design much lower profile, smaller, lighter, brighter, closer to the surgeon's eyes, and behind the field of vision instead of inside of it. We kept the 3 articulating point sources to still allow the surgeon to control the direction and spread of the light, and include more space for more LEDs and higher brightness. This 1:25 scale model of our overhead device shows the concepts involved in our overall design. As shown, the whole system actually slides on rails mounted to the ceiling. The circuitry is all contained in a box which is mounted to the rails. 8 arms descend from the box. 1 is rigid for control. This arm would contain all the buttons and switches necessary for the operation of the device. 3 are articulating arms with cameras attached at the end, here shown with orange tips. And 4 are articulating arms with lights at the end. Each arm has a microphone mount that allows for variable positioning. To dissipate the heat, there is a low-flow fan and form-fitting heatsink that stay below 25 degrees Celsius, keeping it touchable for when the surgeon wants to move the arm. Finally, the LED array generates light only in the visible spectrum, so there is maximum brightness with no infrared heat generated. In conclusion, for the end of the semester, we will send Dr. Gum working prototypes of both our concepts and expect to receive feedback that will be used to improve both systems in following semesters.